Hello, welcome everybody. We are so glad that you're here today and interested in our topic on Pixo's IoT lessons learned. You may have heard we are recording, so just wanted to remind you of that today. And if you're not already familiar with Pixo, we are a software consultancy in Champaign-Urbana that creates custom websites, software, and applications that address unique challenges. I'm Danielle, I'm the account executive for Pixo, and I'm happy and honored to help facilitate today's webinar. Thank you again for joining us. We're going to share lots of information. It may spark questions, and we would love to have you engage with us afterwards if you have additional questions after hearing the presentation today. Next up, I'm going to pass it over to Jenna from the Pixo team to introduce herself.
Hi, I'm Jenna Fry. I'm the account coordinator here at Pixo. I'll be handling the details today, so I'll be putting some helpful information into the chat for you. And as Danielle mentioned, if you have questions throughout the presentation today, you're welcome to share those in the chat, and I will note them and I'll make sure that Jason gets to them. If you'd rather ask your questions directly, we will have time for a Q&A at the end of the presentation today. And also, if a question comes up for you after the webinar, or you'd like to connect with us directly after our time together today, you are welcome to reach out to us afterward. We can schedule time to chat. Our door is open. And as Danielle mentioned as well, we are recording today, so we will be sharing that with you after the presentation today.
Thank you, Jenna. Last but not least, I'm going to turn over the main part of the event to Jason Berg, our president and co-owner of Pixo, to introduce himself and get started on today's topic. It's all you.
Thank you all. Good morning. Yeah, as Danielle said, I'm Jason Berg. I'm the co-owner of Pixo, and I picked up a seasonal allergy, so I apologize. And I just hope that any kind of nasally sound is endearing and not annoying. So today we're going to talk about a subsegment of IoT, and that's interacting with devices and systems via a user interface. And more specifically, about end consumer focused UI. To tell this story well, I'll need to push the boundaries a bit of IoT and delve into some other hardware software integration type projects. They're not the same, of course, but the lessons are transferable. To give you a sense of our perspective, we spent a lot of time at the intersection of software with IoT, manufacturing, AgTech, and higher education. At Pixo, we're known for building well-researched and fully custom software, web applications, and websites that intentionally put people, the users of our software, at the forefront of our thinking and system design. For the 20 years, we have been a majority woman-owned company, which is a deep sense of pride for our team and for our community. And throughout that history, we've focused on untangling tough problems in content, in design, and code. And our aim is always to improve the relationship between people and the technology that they use. So I'm going to go over 4 principles today, and Danielle's going to help run the presentation here. And these are 4 principles that guide software development work. So when we think about software development, we want to make sure that it is usable, adaptable. And so we recommend to the product teams that we work with that they, 1, talk to real users, 2, test out ideas before development, 3, design systems for flexibility, and 4, build systems iteratively. This isn't a comprehensive list of best practices. These are simply 4 areas that we consistently see companies getting wrong with their hardware and IoT projects. Many of us have been beaten down by bad experiences with software. We have been overwhelmed, confused, lost, frustrated, and downright angry at times. And most of that comes from a mismatch between expectations and reality. For example, if I expect traffic when I'm driving around town and it's busy, I'm not nearly as frustrated as when I'm driving around and there shouldn't be any traffic, but somehow I've gotten stuck into a bumper to bumper situation. So we often spend time at the beginning of engagements, helping clients uncover these pain points. And we work to empower them to expect more out of their digital tools and their platforms. And we do this in part by valuing research and user needs over assumptions, clean code and engineering flexibility over blind efficiency, and relationships over rigid processes. And more specifically, we combine UX research and design, full stack engineering to form cross-functional product teams. And by melding these functions throughout the life of a project, our team and our clients can take advantage of the high value feedback and learning that comes from watching people interact with iterative versions of software. Most folks that I talk to, they know the advantages of agile development, but few are able to combine that with UX methodologies. Agile ensures that we only build valuable features that users need, and integrating UX ensures that those features match your users' context and expectations. So let's get into some of the principles. The first principle, talking with real users, is surprisingly controversial, but there really is no substitute for getting into the field and observing folks in action. Most of the value from our perspective comes from watching people do their thing and then asking them questions to better understand how they arrived at that process. This is not marketing or market research. We are not asking what they want in a new product or if they would buy something or how much they might pay. We're focused on learning how they solve problems and under what conditions so that we can design software that is immediately familiar and makes sense to them. I mean, it's 2022, y'all. Like nobody wants an instruction manual. But creating a user interface that seems obvious and intuitive is incredibly hard to pull off. Users have always been annoyed by bad software, but now that they've seen how good things can be, they don't want to go back, which is sort of why I don't buy an expensive wine. I don't want to know what I'm missing. Over the past few weeks, I've been thinking about user expectations in another context. I was preparing a staff training on how to avoid falling for phishing scams. And I'm unashamed to admit that even though I've been on high alert for over a decade and can spot most of these scams really quickly, I was almost fooled last year. This email I got, it was perfect. It spoke directly to me about something that I cared about, and it was designed to feel like an official communication from a common web service. I clicked through all the way to the fake password prompt and was about to put it in when I noticed a few pixels out of place on one of the product logos. It had just been recently updated and I knew it. I was saved by a single imperfection on the very last step of their scam. And I tell the story just to illustrate how tuned most users are to how things are supposed to work. You can create an app that is spot on with its core functionality. But if you introduce a non-standard navigational element, or don't add labels where they should be, or forget about a status message or error messages, it negatively affects the entire experience. It might not ruin your project, but the value to effort ratio for many of these things is extremely high. So at the very least, it's a lost opportunity. A good example of this is when we're working with a steel mill. We were tasked with recreating a custom packing and shipping app, which they needed to run on a rugged handheld scanner. Their existing app, among many other issues, it didn't have a network status message. So every time they turned on their big arc furnace, which was often enough, it interrupted the Wi-Fi signal and the app would briefly stop working. Whenever this happened, the folks came all the way back to the main office to get a replacement device because theirs wasn't working. The amount of time that we've saved with a simple and informative network status notification banner is significant. The more you know, right? So a common alternative to talking with real users is to only test prototypes with internal audiences. Product teams cite many reasons for doing this. They're under time pressure typically, and they believe this will save time. Everybody has budget pressure, and so they think that this will reduce budget. And in many cases, companies actively discourage product teams from talking to customers. Some companies are uncomfortable showing in-process and prototype work to external audiences. What companies don't acknowledge, and most aren't even aware of, is the true cost of getting things wrong. A recent study estimated that the cost of bad UX alone was about 75 billion. And this is kind of an older study too. So if we adjust this for inflation, we don't even want to know what that meant. And we've seen more and more studies come out recently too. So if you're interested in this, Google it, and I'm sure you'll find a much bigger number even than that. If you build software from the inside out approach by starting with an internal only vision of how things should work and not from a user first, context aware, outside in approach, the final product will have a much higher likelihood of failure. And at the very least, you'll spend time on features that will rarely or never get used. I want to talk about a specific example of this. It's a project called Soil Scan. I think we have a slide for Daniel. This project really shows the benefit of getting into the field, and in this case, an actual field. This is a portable nitrogen testing station. The R&D version of this had an embedded Windows CE touchscreen interface, and their internal audiences that were developing this, they loved this interface. For those folks, they looked at it every day, and it was really fast and efficient. However, the company knew that they would need to appeal to a larger audience on product launch, and they tasked Pixo with developing an iPad application that would directly control this product via Bluetooth LE. We learned many things watching folks in the field using the R&D model, but perhaps the most significant in terms of how it affected the final product was realizing that users might be running multiple units at the same time. From our offices, we would have never imagined that people would buy 4 units to save time and allow them to do more fields in a day. The difference between standing at a single station and navigating a complex series of steps and multiplying that by 4 is significant. And it required us to rethink some aspects of our wireframe. As a quick example that may provide some context, when we use the ATM machine, we typically don't leave mid-transaction. We go and we put our card in and we get our money out. And because of this, the interface for an ATM, it doesn't need to hold our hands because we're not going to forget what we're doing at any point in the process. If you were running around to 4 different ATMs at the same time, you'd likely get a little confused each time you moved. Once we collected and compiled our observations, we can begin making informed recommendations about how the information and concepts are introduced, how the choices are presented and organized, and the workflow that makes sense for users, and which minimal list of features we think that the application should start with. So for this testing station, we provided context that a person is likely to have forgotten while working on another machine. So what step am I at? What did I just do? What happens next? And for a machine that required calibration, it had water tank, mini dirt mixer, it was going to be really easy for a user to get mixed up. Oh, and I think it's a mixing pen. So getting into the field, though, is not without hazard. A few years ago, I was on a demo unit of a light vehicle, and it had this new drive-by-wire product that they were testing out. They were developing a software-based stabilizer that would correct for users' tendencies. And this was a pretty early prototype, though. I looked and felt ridiculous driving this thing because I couldn't get it to move straight. And I almost ran over the person that was running this demo at least 2 different times. And we might have a video of this. Is that true, Danielle? So this thing is supposed to make it easy for me to drive this thing, but for whatever reason, I was overcorrecting. And I felt bad because he made me get off of this machine eventually after only driving it for about 30 or 40 seconds. So I didn't really get a good ride in. Now, somebody else got on this machine right after, and they were able to drive it straight. So I don't know what my problem was. An important takeaway for us is that early assumptions about users, and many of them are going to be incomplete or inaccurate, they'll persist into the final product and often will never be corrected. By observing and talking with folks about what they do and how they do it, we're better able to design software that fits who they are. Our goal is to create products that a core audience will instantly recognize, adopt, and use. So on to the second principle. This is testing out initial ideas before development. And we think that this can reduce the risk to your project and your project budget by shifting costly and hard to change decisions later in the process. This is an area of product development that many companies believe in, but many do not start early enough, and most end this process too early. An approach that we recommend is represented well by the cone of uncertainty. I think we've got a visual for this. So at the far left, we know very little about what the final product should be and how it's going to be built. All we have is excitement and ambition, or for folks who might be working at a large organization, perhaps you just suggested something smart, and now you've got this mandate to build something. But regardless, these powerful drivers push us to make decisions before we have enough information to do so. Using low or lower cost methods to test out our assumptions can and often does reduce overall project risk. This can work in conjunction with UX research, informing or being informed by the information gathered. And when we think about this, we also consider the cost of, we've got another slide here, Danielle, showing the cost difference between early in the project, the number of alternatives available to us. And then as we move further and further down the project, the cost of changes becomes extremely high. So the more decisions and iterations and research that we can do up front, the more likely we are to have that final product mix fit what we needed before we get into this stage of the project, just the cost become unmanageable. So what does this look like practically? For one of our clients, we developed a prototype of an application to test out how the market would respond to a completely new product line. This was a 40-year-old manufacturing company that made OEM components for light vehicles. They were moving from this manually actuated product to a computer-based product. And an important segment of this market was the dealers and repair shops that would have to learn how to tune and troubleshoot in a brand new way. Based on the initial research that we conducted, the company decided to deviate from their original plan. If this product ultimately proves successful in the market, they will likely need something more than the prototype app that they're working with. But it's allowing them to learn about this new market so they can make better informed product decisions down the road. One downside is that they now find themselves investing in a lot of resources into propping up something that really won't meet their future demands. But they were able to reallocate about $500,000 of production costs that we had gamed out, at least for the time being. Another quick example is a company that started here in Champaign called Psionic. They're developing this incredibly advanced touch sensing bionic hand for amputees, a lot of them veterans. They need a custom UI for doctors to be able to communicate with and configure these arms in the hospital setting, but they aren't certain exactly which features will be needed. And to keep their costs low, we just provided them with some technical leadership so that their student interns could keep working and we could sort of help keep them from going off the rails. I talk about this example though, because if they had built a full function production UI early on, they might have missed some opportunities to embed these configuration profiles directly into the ARM. They will likely need a new custom app at some point in the future to drive adoption at various health systems. But for now, they're working to eliminate most of the UI needs through adaptive training that the end users themselves can do. So some interesting opportunities that just by waiting, they were able to do. So designing, I think we got a next slide here. Designing systems for flexibility tends to be the most controversial principle on this list. It makes some intuitive sense to product teams, but once development begins, it's clear that any initial understanding of this doesn't go very deep. For product teams that have spent a ton of time developing something, and they've got specs written about how it's supposed to work. And oh, thank you, Danielle. The idea of building in for future flexibility sounds to them like a nice to have. You know, yes, we understand that this software is going to be embedded in a product and that product's going to be shipped out, and that's going to be very expensive and time consuming to change, but trust us, you're going to want to make changes later. That mechanism that we built, over the air firmware updates, is probably going to pay for it before we even get to product launch. When we talk about flexibility at Pixo, we're referring to a number of related methodologies. So I'm only going to focus on one of my favorites, and that's test-driven development, or TDD. Pixo engineers and many other engineers have this mantra. It's the idea that we should keep software soft. And it's one of the pillars that helps us to do just that. At a high level, TDD specifies that before you write new code, you write a test to determine if your code behaves the way you want it to. So you write a test, does this thing do that thing? And the answer is no, because you haven't written the code yet. Then you write the code until the test passes. It took me a really long time actually to not make this sort of confused face every time someone talked about it. But there are two things I really appreciate about this method. The first one is that engineers tell me that they end up writing a lot less code using this method. Less is more here, right? And when we make changes to these code bases, we can run tests and see if the new code breaks any of the old code. It's the second one that really becomes important over time, because it allows our engineers to make changes at a similar level of productivity, no matter how complex the code may get. The reason I appreciate this is because of a very common story that I hear from new clients. And it's some version of this. We hired this development team and they were great at the beginning and they were just pumping out new features, but now it's a year or two later and everything takes forever. Even the smallest change takes a long time. And they think, you know, I think we have their B team now. And that's sort of represented by this image here, where teams can incur a lot of technical debt and make their clients very, very happy because they're not doing any refactoring, they're not planning for the future, they're not planning for changes. And so everything is going swimmingly for quite some time until they start to, the technical debt starts to stack up. And every time they want to make a change, it takes twice as long because they don't know what's going to break or what's not going to break. But there's things to unpack with that story. Your development team, your developer might have a B team. I can't know, but that's probably not the main source of what's frustrating. Over time, your code becomes complex. It has a lot of dependencies. And so making changes, however small they may seem, has the potential to break something. But how can they know? Sometimes it's obvious and you can make a quick correction. Sometimes it's not, and later you get a call from your client wondering why the heck this thing just stopped working all of a sudden. TDD allows engineers to quickly confirm that all the existing tests passed, so they can confidently make new updates. We worked with a company for a number of years on a software platform that allows them to display surface conditions for every segment of every airport runway for an entire state. That's a ton of data. It's a really complex, oh, thanks, Danielle, really complex interface. This is just one screen of probably hundreds. The product team requests improvements and changes all the time. We're constantly updating the software. And they recently merged with a new company that has a van packed with manner of sensors, and they're trying to automate a large portion of the street condition assessments for cities, not for airports. Their code has become quite complex over the years, and yet we're able to productively, we're able to quickly make changes to the code base without fear, which makes our client quite happy and our team as well. We've also moved this project around quite a bit between different engineers. And because the learning curve isn't as steep as it is, would be for a project without test coverage, it's easier for us to do that. This client did wait a little bit too long to talk to some external users, and so it's kind of affected the final product, but at least we're able to easily modify it. So the last principle I want to talk about is building systems iteratively. And I want to quickly make 2 points. The first is that building iteratively using agile MVP methodologies is smart from an engineering standpoint. I think most folks agree with that. But many projects fail to make sufficient room for pivoting and reprioritizing based on user feedback, even internal feedback. This may be because teams lack an integrated UX person, and so the responsibility is often shared between the product owner and the engineering team. And while it is up to the product owner to prioritize changes like this, it's not always clear to them which ones are reasonable and which ones could cause some issues. And when I say issues, I mean budget and schedule being the ones that most folks care about. When we talk about iterative, we're often referring to pushing some small part of a larger system live, conducting user testing, again, not market research, and updating that smaller part of the system based on feedback before running that cycle again. This allows the time and the space to ensure that we don't prioritize big parts of the system that won't get used or would need significant modification to meet users' needs. The second point is that we can use the same level of thinking on existing or legacy systems. Pixo engineers don't really like working on someone else's legacy code base. It's messy, it's not clear what it does. There's often significant sections that are no longer needed, but someone just kept them just in case. If they had used TDD, they would have saved themselves and everyone else a ton of time. For many organizations, though, a wholesale replacement of a custom system is just impractical. We have a client that decided 5 or 6 years ago that they were going to move away from their custom-built system. And knowing this, their engineering team, which was 4 or 5 people at one point, They started responding to recruiters' calls, and eventually every member of the team left. And so they called us in to sort of triage the system. We've now been supporting it for about 4 years, and they are still certain that they're going to scrap this entire system and move to something off the shelf. But I'll report back in 2025 and see how far they've gotten. Recently, though, we were able to convince them to update a small part of the system so they could take advantage of an off-the-shelf piece of software for events. And we were able to separate just enough of the system so we could work with just this one small segment independently. It wasn't pretty at all, but it's working. If we build systems, though, that are designed for change, and we separate out all these major functions from each other, we can build or replace parts of the system independently as they age. And why do we think that's important? Because in 2020, the Consortium for Information and Software Quality estimated the total cost of poor software is in the US is 2.08 trillion. The product failure rate, that is the ones that are canceled before they even get completed, has been studied about 19% of projects for over a decade. And 47% of projects are challenged in their execution. And that is, they are over budget, behind schedule, and produce low quality deliverables. That means that only a third of software projects are fully successful. The underlying causes are varied, but one consistent theme has been a lack of attention to quality. Many fail to recognize the inherent complexity and difficulty of engineering good software. While the report is isolated to software quality and security and never mentions UX specifically, they do acknowledge that most projects fail due to non-technical reasons. And the companies must create an environment where people are seeking out and acting on answers to the following questions. These are among others, but who are my customers and what are their real needs? This morning, I focused more on these steps and methods than on project details, because we think the primary goal of hardware and IoT UI development projects isn't to decide which features to include. Define a development approach that ensures that your new software makes a real impact on your organizational goals and can adapt over time as those goals evolve. Like eating healthy and exercising, these best practices aren't the answers that most folks are hoping for, but they will ensure that you get where you need to go, in your car, with the traffic you hopefully expect. And they will improve your chances for project success. Thanks so much for your time. Love to hear any feedback or questions that folks might have.